Okay, so you might remember in chapter 2, way back when, right, we talked about the median and the IQR. So I'm going to go back to this picture that I drew of this really important information. Okay, so like I drew this picture, maybe I can do it justice, back in the chapter 2 notes where I said, well, the min and max are going to be on either end of my data, right? And I said that the median lies exactly halfway between the two values. Do you guys remember this? So I'm going to keep moving because what we said furthermore was that we had Q1 lying between the min and the median and Q3 lying between the median and the max. And that the difference between Q3 and Q1 was called the IQR, or the interquartile range. Okay, so I kind of want us to keep this picture in mind for a couple of reasons. So first of all, the median and the IQR are considered center and spread when data is skewed in some particular fashion, or it doesn't follow a unimodal and symmetric model. So what we want to think about is how we could display this information so that everybody gets to see where the data really lies. Because this picture that I've drawn you only looks this way because I'm trying to show you that the percentages of data between here are exactly the same. But just because I have 25% of the data between the min and Q1 does not mean that this distance between the min and Q1 is the same as any of these other 25% distances. So what we want to do is we draw a picture of what we refer to as the 5-number summary. All right? And the picture of the 5-number summary is referred to as a box plot. So what we're going to do is talk about what the values are in a 5-number summary real quick, okay? So we're going to do a 5-number summary. That's going to be your min, your Q1, your median, your Q3, and your max. These are the only 5 numbers in the 5-number summary, okay? So first you compute your 5-number summary, and we would use our calculator for this. So we did this before already when we found our mean and our standard deviation, but that's in your 1-bar stats menu, and then you scroll all the way down. It's literally the bottom 5 numbers in the 1-bar stats menu. But more importantly, to help us draw a box plot, because it's really hard without an example, and we're not going to do that until we meet in class together. So to draw a box plot, we're going to need to know one particular other thing. So that's called your upper and lower fences, okay? So I'm going to put a big old box around this because these to me are incredibly important. Your upper and lower fence calculations are crucial. So I'm going to start with the upper fence. I don't know why I always do this, but I always start with the higher value. Upper means higher. These are going to be 2 equations, okay, guys? So we start with the number that we have as quartile 3, and then we literally add 1.5 times whatever value we calculated for the IQR. Okay, so I'm going to do the lower fence calculation, and it's very similar. So instead of starting at Q3, we start on the lower quartile, which is Q1, and we're going low, so instead of adding, we subtract. Same quantity, 1.5 times the IQR, okay? So notice that if I had only computed my 5-number summary, that I first have to find the IQR, which is not a part of the 5-number summary. So the first goal would be to find your IQR and compute your upper and lower fences. And you're like, why the hell do I care? Well, we care because these fences tell us if we have outliers. So if any data falls, I call it outside the fences. So that would mean above the upper, or below the lower. It is considered an outlier. So now we have a definitive definition. Terrible. So now we have a definition. I'll just go with that for outlier, and we can use this to kind of piggyback on what we learned way back in chapter 2. All right. So together in class, I know this is very little, but together in class, we're going to make a box plot, and then we're going to take a look at some box plots that are already constructed and compare them together. Keep up the good work.